Let's begin with question number 6 from this paper. So let's change it to whiteboard, please. Okay. Okay, let's think about it. So the cubic polynomial, so you should be able to see the Q6 here. So the cubic polynomial is fx is such that the coefficient of x cubed is -1. And the roots of the equation fx equal to 0 or blah, blah, blah. 1, 2, and k. So given that the remainder, fx is remainder 8 when divided by x minus 3, find the value of k and the remainder blah, blah, blah. So this is using a theorem called the remainder theorem. It's not really taught in the ATMATS version, not that I know of the SPM syllabus. It's taught in the government school, Malaysian government school, it's taught in Form 6, usually A levels, but in the ATMATS, they do it apparently in the IG level of this paper. So let's look at it. So remainder theorem basically just states that if fx, let's think of it as a polynomial fx or px, normally px, if px is divisible by the linear factor, we call it linear factor, x minus a, then its remainder is PA. No. When divided by this thing, sorry, I'm doing factor theorem. If PX is divisible, yeah, correct. Nothing wrong also. The statement is not wrong. Just I kind of don't want it to confuse a person to think that there's no remainder. Actually, it doesn't really mean that. If PX is divisible, if PX is divided by, yeah, that's the correct English. Sorry, it's divided by, because it seems to tell that it's perfectly divisible, which is not. We assume that it's divided by the English. So if px is divided by x minus a, then its remainder is PA. This is the only theorem they're using for this question. So it's true for any level of polynomial, whatever the degree. Like in this case, they selected a cubic. Okay, what is a cubic polynomial? So a cubic polynomial has the highest power of 3. So cubic polynomial highest power of x is 3. That's the meaning. I mean, it has a term of x cubed, maybe ax cubed with a constant, or ax cubed, or whatever, the number in front. So fx, so I'm just going to write this nicely. Okay, so fx equals to the cubic polynomial here, such that the coefficient of x cubed is -1. So when they say the coefficient of x cubed -1, and then they go and say the roots. Roots means what? Okay, so we need to know these individual words. Roots is also used in quadratic. Whenever you see the word root, please take note. Like root means just take x minus that. It's something like you want to solve x minus 1 becomes 0, and then x equals to 1 is a solution of that. That is the meaning of roots. In a polynomial, the roots are just multiplied to each other as choices. So x minus 1, x minus 2, and x minus k would be that equivalent product for this polynomial. As you can see, the leading term would have been, by just glancing at it like that, x times x squared times x cubed. But the problem is x cubed. There's no negative sign. That is why they added this statement. Oh, so that means they're helping us to determine the structure of the polynomial, which is actually like this. Let's put a negative sign outside. That's all. Okay, so x minus 2, x minus k. Now it satisfies that negative x cubed is the leading term, satisfying this, satisfying the roots, 3 roots. Now we're ready to use the remainder theorem. This one. So to use this remainder theorem as a step, what we do is, so they say fx has remainder 8 when divided by x minus 3. This is the x minus a here. These two are the equivalent statements. So the remainder is PA. That means the remainder is F3. So F3 has remainder 8. That's what it means. Basically, replace x with 3 from here. Put this 0, x equals 3, or x. The a here means here a, put it 0, and then the remainder is 8. Oh, so these two we substitute like that. So what is the answer? By solving that, we'll see. So let's bring the arrow here. Okay, what does it mean? That means that, so we just substitute only. So negative, please take note, because it's the same color, pink color, so easier to see. So it's -1 like that. So I go -2. So it's minus k. And then this equals to the remainder of 8. Why didn't I write the x? Because I'm replacing with, please take note, x is replaced, replaced by 3. Where x equal to 3 in other words, for this to happen. That's why I put the x is 3, 3 minus k. Okay, let's solve this, please. So solving this, we should get the answer. 3 minus 1 is 2, so negative 2 here. 3 minus 2 is 1. 3 minus k is 8. Aha. So 3 minus k doesn't bring over negative 4. And bring that 2 there. 8 over 2 is 4. Solving this shouldn't be too difficult. 3 plus 4, if I'm correct, then the k value is 7. Then one final thing on this, k7 is done. So just put a box around this so that we can do it in one page. Right? So here we have the part 1, right? So part 2, the remainder when fx is divided by x plus 3. So what we need to do for this is, please take note, just copy back the fx and replace the k value first. Just leave it as in the factor form. No need to multiply out and it makes things complicated from here. Put the k is 7. Get it in. So we use the remainder theorem yet again. Second time on this. So that means the remainder theorem tells me that you must put the x plus 3 is 0. This part, So x plus 3, you put 0. The substitution is negative 3. So the remainder is when f is evaluated at negative 3. So let's substitute and calculate that plus. So just put x is negative 3 with this new value. So negative 3 minus 7. So let's calculate it. Plus, so negative 4. This is minus 5. This is minus 10. So when you multiply everything out, negative, 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 negative. So the answer, you can put in a calculator or do it directly. It should be 200. Thank you.